All right, so on this one, we could go about doing some of the other methods that we have done, but I want you to take note of something. If you take this coefficient 1 and multiply it by 6, you get the 6. If you take the 2 and multiply it by 6, you get the 12. I wonder what 19 times 6 will be. So 19 times 6 is going to be 54, carry the 5, and 11. So times 6 times 6 times 6, these are the same line. And they have infinitely many solutions. So how you tell that when you're solving is if you were going to solve by substitution, which is what they asked you to do, we would wind up losing both variables. So let's do that real quickly. So let's solve for x because it's the only one that's by itself. So we would say x is negative 2y plus 19. Getting the 2y on the other side changes its sign. And let's take this core equation and rewrite it, and we'll have 6x plus 12y is 114. And then we take our sub-equation, and instead of the x, we plug in our negative 2y plus 19. And then we distribute, and we get a negative 12y plus 19 times 6. Well, 20 times 6 is going to be 120. So 19 times 6 is going to be 6 less. So it's going to be 114 plus 12y is 114. Well, look at that. Everything cancels and you're left with a true statement. 114 equals 114. So this one, when our x's and y's both cancel and we're left with a true statement, that means they're the same line, which means they have an infinite number of solutions. Okay, this is number 7 on our problems, and this one it's got decimals in it. Can we clear those decimals by just multiplying everything by a power of 10? It doesn't even have to be the same power of 10 in both equations. As long as we do to one equation the same thing on both sides, we're great. Okay, so what if we just multiply by 10 and by 10? Okay, so we're going to get 8x plus 6y is 26, and 10x minus 8y is negative 14. Okay, and that's really much easier to look at, isn't it? So I would even do something else. So when I'm starting to solve something, here I've got 8, 10, 3, 6, 8. What if we just divided the top one by 2 and the bottom one by 2 just to keep our numbers a little bit smaller? So if we just divided everything by 2, wouldn't we get a 4x plus a 3y is a 13? Okay, and on the bottom we would get a 5x minus a 4y is a negative 7. Well, those are easier to look at because the numbers are a little bit smaller. So just doing a little bit can really kind of make things a little easier. All right, so I have written our system a little bit neater on another board. And now since I've got a 3 and a negative 4, I'm going to go ahead and eliminate my y's. But I've got to get them to a common number, and 3 and 4 both go into 12. So what I'm going to do is I'm going to multiply the first equation all the way across by 3 times 4 would give me 12. And I'm going to multiply the second equation all the way across by a 3. So when I do that, I'm going to get a 12y and then a negative 12y, which are going to cancel. But I have to do it all the way across. So 4 times 4 is 16x, and then plus a 12y is 13 times 4 is a 52. Okay, then on the bottom I get a 15x minus a 12y is a negative 21. So now I'm ready to add the two together. So 16 plus, that's a 31x. This cancels. Is a, since that's a minus, that's going to be a 31. So 31x is 31, x must be 1. So now that we found x, we can go back up in and find a y. So let's go back up here and let's put our x as 1 right there in the first one. And we get 4 plus something is 13. 3y must be, if we subtract the 4 from both sides, we get 3y is 9. So that would give us y is 3. And then we need to check that by plugging it into the second equation. All right, so we're going to plug in x is 1, so we'd get a 5. Y is 3, so we get a negative 12 is negative 7, and that is true. So it works in both equations, and our answer is 1, 3. All right, so now we're going into just some vocabulary that we're going to need. If we have a system that intersects in one point, okay, we call this one consistent, independent. Okay, now we went over these in class, but let's just review these. Okay, consistent means it has at least one solution. Independent means they're not the same line. Okay, so now if I have two parallel lines, they're never going to intersect. There's no solution. This one has one solution. And we call this system, well, they are independent because they're not the same line. They are independent, inconsistent. Okay, and then the last one we have is when they're actually the same line. Okay, they're actually the same line. We've seen there's infinitely many solutions. And we call this one dependent consistent. So dependent because they're actually the same line, and consistent because there's not only one, but there's an infinite number of solutions. So consistent means it has at least one. So it is consistent. All right, so those are the categories that we're going through. So now in this problem, it says determine whether the system is consistent or inconsistent and whether the equations are dependent or independent. So we have 3x plus 6y is equal to 99, and 12x plus 24y is equal to 396. Okay, so now this is looking very much like they have the same slope. If I multiply this by 4, I get this. If I multiply this by 4, I get this. If I multiply this by 4, do I get that? Okay, well, if I multiplied 100 by 4, I'd get 400. So if I multiplied 99 by 4, I'd get 396. It would be 4 less than 100. So these are actually the same line. Okay, so since they're the same line, then I'm going to call them dependent, and consistent. Because they have an infinite number of solutions because they're the same line. Dependent, consistent. And their graph is going to look something like that. They're going to be the same line. Okay, I figured that a picture was worth 1,000 words on this one. The figure shows the graphs at the cost and the revenue functions for a company that manufactures and sells binoculars. Okay, so the revenue is 3x, and the cost function is 1,500 plus x. They're asking us, what is the break-even point? Now, the break-even point is the point where cost equals revenue. What you're putting out equals what you're pulling in. And you're not at the point where you're making profit yet. You've just broken even. And to do that, we will set these two equations equal to each other. And when we do that, okay, so we are going to set these equal to each other, and we're going to say that 3x equals 1500 plus x. When I subtract this x from both sides, I get 2x equals 1500, and then I divide by 2 on both sides, and I get x is 750. Okay, so that is the number of binoculars that I'm going to make to break even. And then I have to plug the 750 back into one of the equations. And when I plug 750 in there, I'm going to get 0, 15, 22. So 2,250 would be the amount of money that I would need to break even. So 750, 2250 is the break-even point. So the question was said, how many binoculars must be produced and sold for the company to break even? And they had the answer on the screen. We didn't even have to do any work. But the break-even point is here. We just figured it out. And so they have to sell 750 binoculars to do that. And that is the answer. Okay, so let's see what the next one is. So the next one, I'm going to put this on the right view so we can see the whole problem at the same time. Oh, let's use slideshow. It's a little bit easier. Oh man, it went all the way back. So let's surround. Oh. Okay, so here we are. It says a canoeist paddled 6 miles upstream in 6 hours and returned to his starting point downstream in 45 minutes. What was the speed of the current? Okay, so what do we know? He is paddling 6 miles upstream in 6 hours, and he returned to his starting point in 45 minutes going downstream. So what was the speed of the current? All right, so what I would do is I would make a chart. This is a distance, rate, time chart, and I have it going upstream and downstream. So I've just put my data in there, okay? So I've got 6 miles both ways, and then the rate of the boat going upstream is against the current, so it's going to be the speed of the boat minus the current. And then downstream, the current is pushing it along, so it'll be the speed of the boat plus the current. And it took them 6 hours to go upstream, but only 45 minutes. You must write everything with the same unit of time. Okay, so here's our ruling equation here. Distance is rate times time, which means that rate is distance over time. So now I'm going to go to board 2 here. Board 2 is taking this information here and saying, okay, well, rate is distance over time. So here, rate, which is B minus C, is going to be distance over time, which is 6 over 6, which is 1. So I get B minus C is 1. And then over here, B plus C is going to be 6 over 3/4, or 6 divided by 3/4, which is the same thing as 6 times 4/3. So I end up getting 8/3. And then when I get this, I get 2b is 9, b is 4.5, and the current is 3.5. And those were all correct answers. We're doing our last problem now on this video, and 6.1 will be finished. Okay, so the problem is a student takes out 2 loans totaling $11,000 to help pay for college expenses. I figure this is right down your alley. One loan is at 9% simple interest, and another is at 8% simple interest. For the first year, the interest is $950. Find the amount of the loan at 8%. We're just going to find both loans. So what I did is I set up this information. So I said loan 1 plus loan 2 is $11,000. Loan 1 is at 9%. Loan 2 is at 8%. The interest at the first year mark was $950 that he had to pay in interest for these loans. Find the amount of the loans. Okay, well, we already have one equation. Now we need 2 equations because we have 2 unknowns. So we know that interest is principal times rate times time. Okay, now we don't know how much he put in each individual account, but I do know that the total is 11,000. Okay, so let's do this. Let's solve for one in terms of the other. We know that together they equal 11,000. So if I let this one be loan 2, because we're trying to find, well, we'll just do loan 1. So we'll say interest is going to end up being loan 1 times loan 1's interest rate, which is 0.09, and the time that they're going to keep it in there is 1 year. So we can just put a 1 or ignore it totally. And then plus, he's got 2 loans, so that interest is including both, and we can go ahead and put $950 right there. And then plus what he owes for loan 2. So loan 2 is 0.08 times the 1, and we won't even put the 1 down. Okay, so now we have the $950 that he owes in interest comes from L1 at 0.09 and L2 at 0.08. So do we now have our 2 equations and our 2 unknowns? Okay, so now look what I've done. I've taken the 2 equations and I've simplified them just a little bit. This one's pretty much the same. I just switched the order. This one was, I had L1 plus L2 is 11,000. So I said L1 must be 11,000 minus L2. So I solved one for the other. So now I'm going to take this as my core equation and this one as my substitute equation. So I got 950 equals 0.09 L1. Okay, so I'm going to, here's my L1, and I'm going to substitute all of this plus 0.08 L2. Okay, so right here I'm going to put 11000 minus L2. So now let's distribute this through. One of the things we can do to make this a little bit easier is we can get rid of the decimals. We can multiply everything by 100. We have to multiply this by 100 too. So 95000 is, now we're going to go ahead and move that one over because we just multiplied by 100 on both sides of the equation, and that looks a little bit cleaner. Okay, so now we've got 9 times 11,000 is 99000 minus 9L2, and then plus 8L2. Since we moved that decimal over, that's pretty easy. So now, can we subtract the 99,000 from the 95,000 to get negative 4,000 is negative since we got negative 9L2 plus an 8L2, that's a negative 1L2. Well, when you divide both sides by a negative 1, or multiply both sides by a negative 1, we get L2 is $4,000. So L2 was 4,000. So if L2 is 4,000, then L1 is going to be 11,000, take away 4,000, or 7,000. So he has L1 at 7,000, L2 at 4,000, and those are the correct answers. And that is the last problem on this PowerPoint, and that's good because it got rather long, and hopefully you understand 6.1 much better, and we have one more PowerPoint left in the class, and that will be next time. This is Mrs. A, and may God bless your day.